Hi everyone, welcome to Brickless Battery Saving with Ubuntu Touch. This is a talk that's all about the tools that we can use to make Linux on mobile devices just as popular and just as useful as Android and iOS. That's a pretty big one, I know. I'll be talking about what Ubuntu Touch does to save battery and what, well, everyone else, meaning Android and iOS, does now. Hi there, I'm Dalton. I'm the development manager for Ubuntu Touch at the UBports Foundation. Ubuntu Touch is the open source replacement to Android or iOS. If you're interested, you want to learn more, you can head over to devices.ubuntu-touch.io, see if it works on your device. You can find us on Telegram at UBports, or if you want to join us on Matrix, you can find us at #ubports:/matrix.org. I love researching, observing, and explaining technology to other people. I love going back in history and seeing why we do things the way that we do today. And I did a lot of that kind of research for this talk, seeing how people in the past managed to save battery on devices that were much less capable and had much smaller batteries than we have today. The talk itself today is all about the impossible situations that users ask us to fulfill. And it's about the eternal truths that we can use to actually fulfill those requests. Basically by fooling our users into thinking that we did the impossible for them instead of actually doing the impossible thing that they requested. It's a talk about learning from those who came before us, including, well, BlackBerry, Palm OS, Mamo. But I'm going to stay really high level in this talk. I want to start a discussion with other mobile Linux operating systems, that's a mouthful, about how we can manage to save battery for all of our app developers, how we can help developers do this with us so that we actually give users what they want. This talk will also answer the eternal question, why is Ubuntu Touch so weird? Anyone who's used Ubuntu Touch before and tried to run like Firefox or Telegram desktop on it says, well, why doesn't this work right? Hopefully this will do a bit to explain why. At the base of it all, the problem that we have on mobile devices today is that people want impossible things. They want a task that they start to run until they stop it. They want it to run always and forever. For example, if I were to install an email app on my phone, I would expect that I get email until the end of time on my phone. And anytime that there is an important message that I receive, I want to be notified about that. Same for Telegram. If my friends or my enemies are trying to contact me on Telegram, well, I want to know about that. I want to be told about that. And if I buy like a smartwatch, I expect that that thing is always in sync with my phone. If I'm getting a notification, it better be on my watch too. Time better be up to date. And I expect that to be done without manual intervention, which is kind of the important part here. Sure, we can pull or refresh whatever we want, but that's not too useful. This is something that we usually refer to as always on or constant connectivity, where our applications are always available, always connected, and always up to date. The problem is that we also want to get long battery life while having all these constantly connected things going on. And there's a little problem called the laws of physics. Every task that we do on a CPU or a GPU or a network, some network hardware, takes energy. And we have limited energy available from the batteries of our devices. So if we just run tasks always, forever, we don't actually end up getting good battery life. And that's a problem that we have on Linux smartphones today. You can either choose, like with the Pine phone, to have a useful device that receives notifications from more than just SMS and phone calls, or you can have a device that lasts longer than 12 hours on a charge. And that's not a very good compromise to make. That's the old way of compromising things. That's how we've been doing things since 1986 on the IBM PC convertible in the PC space. Yes, I said that I researched back really far for this. Might be worth a blog post, what I learned sometime. Either your laptop is running tasks, it is getting your Telegram messages from your friends and enemies, it is receiving email, or you shut the lid and you're not receiving anything anymore. The laptop is effectively off. And that's a problem that we have persisted on the smartphone. We need to get around that. And we can try to do that by just saying, well, let's just not compromise. Let's just let apps do whatever they want, whenever they want. And in Linux, we have this really great thing called runtime power management, or opportunistic idle, which means whenever your device isn't doing something actively, it can idle. Everything that doesn't need to be running isn't running, and you save energy that way. But we end up with some problems when we try that. We don't hit idle often enough. For example, on my Dell XPS 13 9370, which is the laptop I use every day, if I were to close all of my applications, all my Nextcloud stuff, and just leave Wi-Fi on and leave it connected, it receives 65 hours of battery life with the screen off. That drops about half once I open Telegram and Discord, IRC Cloud, Element, and Thunderbird. And I only get 26 hours of battery life with the screen off and never turning on. I never received a notification during this time because I'm a sad, lonely person. But that battery life dropped by half. So if we could say get 1 day of battery life on a phone, once we run all of those apps and actually get notifications like we expect on a phone, we're only going to get 12 hours of battery life. And on the Pine phone, we're only able to do 12 hours of battery life without aggressive power management, which is something I'll talk about in a little bit. And then, if you do something wild and crazy, like open up a Chrome tab with CNN.com in it, no ad block, and just leave that running in the background, you get 9 hours of battery life, at least on this XPS. This isn't a very good experience at all. That is a really short for something that is suspended or the screen isn't on. And that brings us to some eternal truths about saving power on computers. Idling is good. When we're idle, we use less power because we're opportunistically turning off pieces of the system that we don't need. But idle means idle. It means that absolutely nothing can be happening in the background. And that can be a problem for our current applications. They don't know when to stop processing so that the system can actually be idle. Easy for me to say. Another eternal truth of power management is that it takes more energy to go from idle to running than it takes to go from running to rather busy. Going from 0% CPU usage to 1% CPU usage is a higher jump than going from 1% CPU usage to, say, 25 or 50% in terms of the amount of energy that you're burning off into the atmosphere. And therefore, it's better to idle less, but for longer periods, than it is to idle more for shorter periods. When we look at the power usage of our devices, or the CPU usage even, we want it to look more like the graph that I have at the bottom of the slide, where there are huge valleys and huge peaks, rather than a lot of hilly landscapes. Because as you can see in that slide, this is actually the power usage of my laptop. When it's in idle, there's a huge peak from going from no CPU usage to some CPU usage. And that can amount to a significant amount of battery power used. The problem that we have is we assumed that users actually want constant connectivity. They want their tasks and their applications to be running always and forever. But there is an easier solution that actually is much harder to pull off in practice. I always want my applications to be up to date isn't the same as I want my application to be running all the time. It means I want it to fool me into thinking that my applications are running all the time. It just needs to be a good enough illusion of constant connectivity, not actually constantly connected applications. So then we need to compromise the other way when we talk about saving power on mobile devices. You might think, well, we need to tell applications, okay, so Discord, you're running right now. Element is also running right now, and it's going to check for its messages every 5 minutes or so. So you should check for your messages when it checks for messages. That way we have longer valleys of idle. The problem is applications don't need to care about other applications running on the system. That's not fair to an app developer. That just makes them implement a lot of stuff they don't care about. Luna asks, could you just update fast when the app starts to be active? No, not really, because you want applications to be sending you notifications like I just got on my phone now when people message you, even if it's just sitting on a desk and appears to be doing nothing. So what we actually end up doing in practice then is suspending apps whenever they aren't in use. Whenever an app is focused, it is not paused, and it knows I can process whatever I want right now. And then, when an app isn't focused, we pause it. And does that mean that there's just no worries? Well, not exactly, because there are things that you want to do in the background. You want to check for emails, you want to update chat lists, and you want to notify the user if anything exceptional happens. We'll talk about that in just a moment, but it's worth noting that if we suspend applications in idle, we go to a state where we know when the system is doing something and when it isn't. It's a system-managed state, and that allows us to do aggressive power management, like manually shutting off the phone or putting it into suspend and waking up a little bit later when apps requested to wake up. That's how we get good battery life on the Pine phone, is by not actually having it in idle, but having it in suspend, and just fooling you into thinking it's only idling. Now, this will make people upset because they want to run the same apps that they run today on their phone. They're going to say, I wanted real Linux on my phone, not this thing that you're giving me. Trust me, I hear this every other day. The thing is, they aren't really saying, I want the exact same apps that I have on my laptop. They're saying, I want the same experience from these apps that I have on my laptop. I want Telegram to run, and I want it to tell me when I have new messages. That doesn't necessarily mean that they want the same Telegram desktop app on their phone and their laptop. It'd be cool if they did, though. If the Telegram desktop app was able to work when it was suspended in the background. We start giving applications back the ability to run in the background step by step. And that allows them to create the illusion of constant connectivity. Whereas, well, devices are kind of useless when everything is suspended, whenever the screen is off, we start giving apps back the opportunity to run in the background. And this is something that we schedule as a system rather than as a bunch of apps trying loosely to work together. The problem is that whenever we make a more convenient option, a more flexible way for an app to run in the background, it becomes less efficient. The more that app developers are able to dictate exactly when their app runs in the background, the less battery we have. So that's a trade-off that we need to be aware of. Also, the more clever we need to make our illusion, the more that we suspend in the background, the better battery life we get. But it's harder to implement those clever solutions. We then go, so we're walking back the restrictions that we placed on app developers, and we're walking them back in phases. First off, we make the required background services, the things that basically everyone wants from their smartphone. We make dedicated services to provide those applications. Next, we create push services, which allow application servers to tell the device when they have data to send. From there, we go on and create background extensions, allowing applications that were in the foreground to run in the background for a short period of time. We move on from there into maintenance tasks for things like refreshing your RSS feeds in the background when you don't have a server component that can tell you when there's something new to see. And finally, we end off by implementing the easy button solution, and that is actual real daemons like we have on current systems today. I would recommend implementing in this order, and, well, Ubuntu Touch is currently on the path. We have the required background services and the push services that allow us to do this kind of thing, and to a point kind of have the background extensions. But this is just as much a proposal for how Ubuntu Touch is going to continue developing so that our app developers get their expectations met and their users' expectations met, just as much as it's a recommendation for how everyone should do this. Basically, what I'm saying is we're probably going to do things this way, whether people join us or not, but we would love to have you join us. Let's see. Yeah. We start off by implementing the required background services, the things that people will want the absolute most. And we do this by, well, seeing what users use on their device most often. We target the things that they do most often on their device and why they want their apps to run in the background. The first one of those is media playback. People want to play audio or video even when the screen is off on their device or the application playing the audio or video isn't in the foreground. People want to upload and download files. Well, apps want to do it for things like creating a social media post. They want to upload files even when they aren't in the foreground, because that could be a long-running task. The user could get bored and switch away while they do it. We want to provide location updates to applications. This is something that Ubuntu Touch doesn't do yet. The other two are things that it does. But if an application is using location services, it wants to be updated when it's in the background when the user moves. For example, if you have a run tracking application, the user might be switching applications and running while browsing the web, or they might have turned their phone off, which is more likely. And the app should continue receiving location updates when that occurs. And then finally, people want to create alarm clocks so their device wakes up and wakes them up when they request it. Excuse me for just a moment. Ooh, much better. Those are our required background services. And once we have those in place, we're able to provide the experience of an iPhone 1 in 2007. Well, actually the iPhone 3G in 2008 when they opened up the App Store to developers. From there, we move on to what iOS 3 added, and the iPhone 3GS debuted with in 2009. We're only 11 years behind now. And we create push services. Push services flip the script on client devices. Whereas usually, when you're running Telegram or Discord on your devices today, they ask the server, hey, do you have content for me? Do you have content for me? Do you have content for me? We instead make the server tell the client device, I have content for you. This is much more efficient because the server already knows that it has content available. Why doesn't it just make the client aware of that instead of the client needing to check in, even though there might not be new content on the server? It's kind of like a publish and subscribe model, except instead of polling like you would do in RSS, you get pushed the information that there's new data available. We make the server tell the app, I have data for you. This can enable a lot of experiences. In fact, implementing a push service, which is done by creating a client service on the device, which holds a connection, a single, usually TCP connection, to a server somewhere, that is the push service, and then app servers tell the push service, I have content for this device. The push service tells the device there's content for you, and the device can then pull the content from the application server. Implementing these isn't easy, but it allows us to do things like, well, get notification cards even when a device is seemingly asleep and off. It allows us to grab information, like if you had a newsreader app, like an RSS feed app, and it had a server component, you could have the server tell the client there's content for you, and then as soon as the user opens the application, their news is available for them. They don't need to wait for it to refresh. So not only does this enable being able to do things in suspend, it also enables apps to continue being refreshed even though they appear not to be running. Of course, there are some cons to this model. Of course, first off, the actual push service itself is kind of hard to implement. UBports already has a push service for Ubuntu Touch, but it's based off of some test code from Canonical when they were developing Ubuntu Touch. And it's not the huge, big, scalable solution that Canonical originally had. But it's also centralized, whereas there are new technologies coming up, like Web Push, which enable decentralized push services, where your client subscribes to your server, and it tells app servers, hey, you should send notification content to my server. Whereas with a centralized system, it's just, there is one server, everyone subscribes to that, and if you don't like it, well, you can go away. That's not ideal, especially for use cases where maybe you don't have internet access, maybe you're a company that is air-gapped on your network, but you still want to provide these solutions. I think Web Push is the way to go for this. It is a W3C, I think, standard that is in progress, and it's already implemented for Firefox. So we can take some of that implementation and reuse it. Of course, with Ubuntu Touch, we already have a solution for this, so that's future stuff where we're going to be replacing that. But I do plan on it happening because Ubuntu Push, while it's wonderful, it's nearing its time. Also, your app servers need to be centralized in this model. You can't have apps that are only available on the client and have no server component. I think this might be okay. I think that it might be okay for open source projects to start having hosted services components that you can choose to run yourself that talk to maybe an applications or a push server that you run yourself, or maybe one that someone else runs. I think it wouldn't be bad for open source projects to run hosted components like that, especially if we want to talk about open source projects maybe getting services revenue. We just talked a little bit ago about increasing revenue to open source projects. That could be a possible way, is by having them be services organizations that provide push services for your application. But that's getting way off. I'm sorry. I need to move on. At this point, we can enable most, if not, well, we can enable most use cases on mobile. We can enable things like RSS readers with services components. We can enable voice over IP applications by having the voice over IP server tell us there's a call incoming. And we can enable just getting notifications from Telegram and stuff. But there are some use cases where none of those really work. So we move on to background tasks, actually allowing application code to run in the background. Because up to this point, we've usually not been running application code. We've been running centralized daemon code on the device that then chooses to tell applications specific updates. With background tasks, we split common work that applications want to do in the background. And we know that they want to do this because they do it in Linux desktop applications. And we allow applications to do this. We've split this kind of work into three main categories. Work that the user requested would happen right now as your application is transitioning to the background. And then work that applications would want to happen sometime in the future. Doesn't really matter. And finally, work that applications would want to have done at an exact time in the future. It's worth noting, as we go down that list, the more flexible options give you worse battery life. So if we're giving app developers more control over exactly when they run their tasks, We need to be really careful about scheduling those, otherwise we ruin battery life for the user. And that's bad for both app developers because their users complain that they're getting bad battery life after they installed their app. That's not fair. And, well, it's bad for the system because they say the system has bad battery life. So as much as we can get applications to use the services I'm talking about first, rather than the ones I'm talking about last, the better. We start with background tasks that we want to happen now. These are things like rendering a 3D scene in Blender. You kick off a render and then you get bored, so you switch off your phone or you head over to the web browser and watch some funny cat videos. Or compiling software, Visual Studio Code. Or transcoding video before you upload it to a chat service because someone just took a mean video of you and they want to show you. On iOS and Android, this is fully possible. They both have this implemented, and of course they have everything I talked about before implemented. They give you a few minutes after you're in the foreground to finish your work. And if you aren't able to finish your work in that time, don't sweat it. Pause your work, and then notify the user that you ran out of time and they need to come back to your app to resume. Android makes things a little bit more flexible because you can just notify the user that you are continuing to use more time, whereas on iOS, you need to say, please come back, we didn't finish what you asked us to do. Just a bit of a difference of opinion between the two platforms there. We move on to background tasks that you want to happen some nebulous time in the future. These are really inflexible because basically you're telling Mr. God King system, please do this thing I am requesting you do at some point in the future. And then the system chooses to schedule that at some point that is useful to it, to minimize wake-ups, to ensure that it's safe to use the data connection, to make sure that the user isn't present so that we don't ruin their experience of their foreground applications. You would use this for things like cleaning up your database or refreshing app content, like if you have an RSS reader that is local on the device and you need to go out and check all these RSS feeds, you might use a task like this to do that, because it doesn't really matter that the user gets their content immediately when it happens if they haven't requested push notifications. It just matters that you don't take a long time to refresh when it's time for the user to open your app. A good scheduler lets you do things like, I only want these tasks to run when the device is on charging. iOS allows you to do this with background tasks, and you have absolutely no control over when iOS does these tasks for you. You basically say, I want to run this machine learning algorithm, and the system says, okay. And it never says anything again until it's done. Android allows you a little bit more flexibility again with Work Manager, and you can constrain your tasks to run when you're on battery, when you're on Wi-Fi. You have a lot of options there. And then finally, you have background tasks that you want to happen at an exact time later. These are the most flexible, but they give poor battery life. You say, every 15 minutes, I would like to refresh email so that I can notify the user when they have new email. And I don't have a server that I can use to notify the user when they have new email via push service. On iOS, you can do this only if you are Apple. You have no other options. But on Android, you have some options. You can use Work Manager scheduled tasks to get an approximate task completed. This would be best for email because it's not essential that the user gets their email every 5 minutes exactly. Instead, we can allow the system to schedule tasks as they work. For example, if you schedule something at 1:01, you schedule something at 1:02, and you schedule something at 1:03, well, the system can just say, well, why don't we run all those things at 1:03 to save more power? Android has two options for this. Work Manager scheduled tasks are approximate, and Alarm Manager you would use if you wanted an exact task in the future. Although, with Android 8 and up, there's doze mode, which actually makes your exact tasks run at some point in the future, unless you say, no, really, this needs to happen at an exact time. Again, these are only examples of implementation, not exactly, we don't need to follow them exactly, but given that both iOS and Android have 12 years of experience on this, I think we should take heed. When literally everything else we have provided has failed, we give applications the opportunity to make daemons. And these are services that run all the time in the background. these are really unsafe because they make it impossible for us to do aggressive power management, because we might end up conflicting with what the app wants to do in the background. So basically, you just have to hope that the application developer made safe backgrounds, or made a safe background service. We have to look at the most common reasons why people would use these, why developers would create apps with these, and try to solve them. For example, it might be an issue of not being able to launch an app at the right time to respond to events that happen on the device. For example, if you're Nextcloud or Bacula, and you want to back up a user's content exactly when they take pictures or modify stuff, well, then we might want a better content model where a saved file is able to notify multiple applications that there's new content and launch them, so that they don't need to run all the time. However, there will be some cases where there's just nothing we can do, like decentralized and latency-sensitive applications like voice over IP, where you have 30 seconds to understand that there's a call coming in, or you've missed it and you've failed. Voice over IP is really about the only thing I think of for these kinds of apps, but there are of course more, because I am small-brained sometimes. And of course, finally, there are the applications that will expect incoming connections, like an SSH server or a sync thing instance, where you can't go to sleep anytime, because at any point, anyone from anywhere could say, I would like you to respond to me now. And basically then we have to say, well, if your phone is a server, it gets battery life like a server, like 30 seconds, because it has backup battery for the hard drives. And apologies, lapse of judgment there. So to recap, people want their computers to run their tasks forever, but they also want good battery life. And these two things are in constant conflict with each other. So we need to think about some of the eternal truths of power management. If we're idle, we can save power, but idle means there's absolutely nothing happening in the background ever. And the state to go from idle to running uses more energy than going from running to busy. So the more tasks we can schedule at once, the better. Applications have trouble making that kind of thing happen themselves, and we don't need to make services that tell applications everyone else is running. So we start by suspending them absolutely, and then we help them to create the illusion of constant connectivity rather than genuine constant connectivity. We start by suspending all applications, and then we give app developers the tools they need to run in the background the way that their users expect, so that they don't get the, I wanted real Linux on my mobile phone snark. I want to do this together. Like I said, Ubuntu Touch is probably going to go this way, whether people join us or not, because these are the things that our users expect, and these are the things that our app developers expect. If you want to talk more about this with me, you can find me at Brickless at daltondur.st, or go to daltondur.st/LAS2020, where I have all the slides from this presentation hosted. Or you can join us at UbiPorts. Go to forums.ubiports.com, open up a thread. I'd love to talk about what I got wrong in this talk. I'm at UniSuperbox over there, or Twitter, at Universal Superbox on Twitter. Again, I'm really passionate about this kind of thing, about saving battery, and I think that it doesn't only need to be something that happens on desktops. I will take questions now. Or on mobile phones. I think this can also be something we do on desktops to allow more than just our mobile developers and our mobile users to get this kind of battery life. Excuse me. Okay.
Hi.
I'll take some questions now.
Okay, thank you so much for your talk. It's actually really interesting, and I know a lot of people also had so much conversation about it on the public chat. And so we have a couple of questions here. The first is there a standard for push notification? Will it work for services like Telegram or Google?
So that is one particular problem. There is kind of a standard for push notifications. Actually, there are multiple. There is a web standard for push notifications called Web Push, which is a app server, push server, and push client specification. That's probably where we're going to look because that's where the most developers are going to be putting their effort into, but they'll still need to implement special cases for applications on mobile devices. So they'd create a web push client for their web app. They'd also need to make one for their Ubuntu Touch app, or sorry, their Linux mobile app. Got
Okay,
Ubuntu
thank
Touch
you
on
so
the brain.
much. So the second question is, what are the battery implications of having potentially multiple wake-ups for multiple decentralized push services versus the single wake-up with grouped notification from a centralized push service?
That is an excellent question. It is something slightly that you need to benchmark, but generally on desktop Linux now, we have the case of multiple different push services as opposed to one single push service. So like, I'm pretty sure, though I can't look at the code, Discord is doing exactly this. They open one WebSocket connection to their server, which allows the server to tell the client you have new content instead of actually asking, do you have new content for me every few seconds? So the battery implications of having multiple decentralized push services are the implications of battery that we already have when you are running applications on a Linux desktop.
Okay, so we still have somebody trying to type a new question. So let's quickly take the third question. Does Ubuntu Touch use C groups for managing resources of apps? If not, from the audio talk at last, it seems like it could help for management of suspending apps, RAM, CPU time, and etc.
I forgot to mention this in the talk. Yes, we do. We suspend applications via C groups. Canonical started that with Ubuntu App Launch years before we're talking about doing it now. But yes, Ubuntu Touch already does that, so apps can have multiple processes, and we suspend all of them at once and resume all of them at once.
Oh, great. Thank you. So let's take the last question. So will this kind of power management system be available also for laptops and desktop Linux?
Boy, I sure hope so. I would love to have better idle battery life on my laptop. And basically, that's what it comes down to is if we have this kind of thing available. On desktop, we don't necessarily need to suspend all applications in the background. But if they can better say, I want to run work in the future, like I want to update my application code at some point in the future. When your laptop is sitting on your desk suspended, it can receive that new application code, like Discord needing to update sometimes. You don't need to wait on it or manually restart the application. Your laptop just does it while it's sitting on the desk.